How many of you use Sentry? Something like 100, and it's 100 to 150,000 companies use Sentry. If you don't understand the scale of that, the biggest competitors in our space in the world have a fraction of that, and the sum of all of our competitors in the world have less than that. However, we make less money than some of them because we charge a fair price, and that's the cheat code. But that comes with it a lot of interesting opportunities and a lot of interesting problems. So it makes the business function pretty well, but with it comes a lot of interesting like edge cases. And if you've used Sentry, and especially if you've used JavaScript, and even if you haven't used Sentry, you've probably seen a JavaScript error and you're very frustrated by them. I am frustrated by them every day. There's new ones that we keep coming up with somehow. They're caused by all sorts of things, browser sandboxes, transpilers, I don't know, our own code. Once in a while, it's our own code. But what's really annoying about them is they're often hard to understand. And so we're going to talk a little bit about that today and what Sentry's been working on in that space. And so this was kind of like, if you pretend we have a mission statement that makes sense, this was kind of it. But generally, we like to think of Sentry as our goal is to make it easy to debug software, to find bugs in that software and go from there. And for a long time, we've been doing that with this concept of if we could interconnect all the data, the cryptic JavaScript errors will be easier to understand. I kid you not, this is like the strategy of the company. I'm not exaggerating whatsoever on the JavaScript front. And so we did that with this trace ID. And if you're not familiar with the trace ID, it's something like a GUI, a UUID, a random string of characters that you pass through every single thing that happens in the system. So you load a website, say like Sentry, we generate that ID, and then we string it along to every request downstream from there. What's really cool about that is, especially if you use JavaScript, but also if you work in the real world, you have many different systems that are interacting, and at the very least, you have a front end and a back end. If you use Next.js, by the way, you still have a front end and a back end, so this still applies. And generally what happens is you have a bug somewhere, probably on the back end, it shows up on the front end, and then you see something like a hydration error or some other cryptic JavaScript error, and we're like, you know what we could do? We could connect all of it together, and then when you have that cryptic error, we can show you actually what was going on. And so we've been spending a lot of time on this, probably like the last 5 years now, and we string together everything in Sentry. It's great, it's cool, makes a lot of sense. I don't know, this technology is probably older than I am. Maybe not, I'm pretty old these days. But either way, it's not a new idea, it's my main point. We've been investing a lot in this because as you build a company, the goal is build one great product and then build another great product, build another great product, and then you become an enterprise business. And so that's where this kind of came from. But we had the same thing that half of us are here for, and if you've had a job for more than 5 years, you probably had this like crisis where you're like, oh shit, AI. Like, am I unemployed? Especially if you read the headlines. It's like something about like all of us are gonna be unemployed with AI writing code. But if you actually use any of the agents, if you don't, trust me, your job's safe. But you have this existential crisis for, I should keep track of time. Oh, there we go. This existential crisis for what are you gonna do with LLMs now? Do they replace everything we built? Do you have to adapt? Do they replace your job? All these little things, right? First, they don't. Software doesn't change. The building blocks of software are still the building blocks of software. It's really important to think about this because it matters in everything we do. Systems don't change. Software doesn't change. The way systems and software interact and run and get built, all of that's the same. It's effectively just the way you should think about this is a growth market. So when you think about like, okay, AI exists now and we're a pre-existing company with a lot of customers, a lot of technology, how do we leverage it, not how do we be afraid of it? And so for us, that starts with fear. And it starts with like, do we have a moat? Do we have defensibility? Nobody does, by the way. The only thing you have that's remotely close to defensibility is distribution. We have a lot of that, which is good, but it doesn't mean we're secure. And you see this like Cursor. Cursor didn't exist, and now they're just like a titan. It's still a small team, they're still early, but it's huge, right? So distribution isn't even a moat anymore. And so this is really important. And so we went down this rabbit hole of like, well, what are we gonna do? How are we gonna adapt? And it's not how are we gonna throw everything away. And this is really, really important because it's a growth mindset, not a private equity mindset, if that makes sense to anybody. And then what we quickly realized, and this is how I explain people because I'm kind of dumb, is LLMs are effectively pattern matching. Sure, somebody in here is gonna be like, no, that's not what it is, but it's more or less what it is. And when you look at it, what is a lot of what we do in software? Well, it's like theory crafting of how it's working, how it should work, finding the patterns in it, especially when we're debugging problems or debugging issues or errors. It's pattern matching. I go in and I look at a JavaScript error, I'm like, oh, I can reason about what's happening because I can see the pattern or I've seen the pattern or some other thing, right? We've all done this, makes sense. And so we're like, okay, how does that apply to Sentry? And so then we like did a slight pivot. So like Sentry will find and fix bugs, hypothetically. And we talk a lot about this, and so this is sort of my, my POC of product messaging today, by the way. We have this thing called Sear, which you might have seen on some buses or some billboards somewhere, which we are defining as like an AI debugger. And I'm gonna talk a little bit about that in the 8 minutes. Under the hood, it's complicated and not complicated. And you should understand like what this is fundamentally, it's a way to build a bunch of context about your production system and bring that into something like a coding agent. So when you do need to address a problem, it has a much higher chance of actually addressing it. And we expose this in a couple ways in Sentry today. We expose this in a little widget. This is gonna change over time. A widget, which I'll talk about in the UI, which tries to root cause. Phenomenal job, by the way. It root causes your code. It can potentially generate a fix. We'll talk about why that doesn't work at all. And it can review your code pretty effectively. This should not be confused with a prompt. And anybody that like is not super familiar with the AI space, prompts are not that powerful. They're very important, but it's a lot about the tool chain, the context that goes into it. And so what we've built is a big context retrieval engine. It's not that big yet, but it's getting really big. That makes these things like much more reliable and accurate. And then we try to apply that to different things that are not chatbots. And so there's a really important concept within this though. I'm gonna talk a lot about like automatically fixing bugs. You should know it doesn't work whatsoever. And if you've tried to use an agent in any autonomous way, you'll know exactly what I'm talking about. Because immediately you have to intervene all the time, every single time. And so just take that for what it is. We're not there yet. This is sort of futuristic, but it doesn't mean there's not value today. And so when we went through this, the first thing we realized was because of that is there was this great invention called MCP. Some of you probably are like, MCP sucks, CLIs are great. Doesn't really matter. But what this did is it allowed us to create a human-in-the-loop system in other people's coding agents. That is, we could take Sentry's data, stick it in a cursor, and Cursor could hate us for all we care. They could be like our arch nemesis, and we're still able to do that because it's like a reverse integration protocol. And this is why MCP is so beautiful to companies like Sentry, because we are able to build this great flow where you plug it in, and all of a sudden you can drop in something like a Sentry URL. Sentry will feed in the right context through the MCP, and this is very curated context. And all of a sudden, it will actually often one-shot a fix. It's not perfect in the sense of like, it might not be what you did, probably doesn't write tests. If it does, it probably mocks them in some really bad way. You've all probably experienced this if you touch any agents. But it will surprisingly, like many times, just get the bug correct. Now, once in a while, it will fix the wrong thing. And this is particularly a problem, and I'll talk about this with Sentry, because what we do is we feed it in all this information. And sometimes it's great. It knows what that information is. And for example here, this is like a semi-okay stack trace in Sentry. It's not great. It's not great because it has no source code. It's not great because these lines at the bottom don't have any function names. Agents can figure out what this is because they're very, very good at pattern matching, and there's enough information collectively in the systems to figure this out, which one is already awesome. So that means we can change how technology works. Maybe we can kill source maps. Maybe they never have to exist again. I don't know. But what is really interesting is when you run this through our root cause engine, it will actually go across that entire trace that I was talking about earlier, and it'll actually figure out how the system is working, how it might maybe supposed to be working based on like whatever is in the models and what's not. And this is kind of where the nuance comes in, because what will happen in here, and I don't know, which one do I have up here? This one's fine. I had this error in our MCP, which was, we have this endpoint, which was returning, frankly, what I think is a poorly designed set of data. It was returning two different types of data, and we're at TypeScript AI, so we can all appreciate how annoying that is to deal with. So it was a union. It was an array of two different types of data. It was supposed to be returning trace, which I thought was spans. Doesn't matter if you don't know what these words were. It was returning spans and errors. Okay, I didn't realize that. I didn't read the source code. I sort of winged it. It threw an error. In this error, which I'm not gonna jump into the actual live then because it's complicated, there's no way you would have known that it was returning spans and errors. It's like a Zod parsing error or whatever. It doesn't say that. But what you do know inside of Sentry, if you clicked around lots and lots of times, is the downstream service call that was happening. You know what the source code was in that downstream service code, and you would easily see that it's returning both types. And so we ran, and I don't remember which slide's which, I guess they're over here. We ran autofix on this, or I guess this is root cause. There's sort of two steps to this, but we ran Sear on this, and call it 9 times out of 10, it one-shotted the correct solution. The variability of what the solution looked like was slightly different, but it got it right. It's a simple fix. It's just like create a new schema type, union it, whatever. 1 out of those 10 times, it decided it should change the downstream service so the downstream service no longer returns a union of these entities. And I'm like, I don't totally disagree with it, but that would break a lot of systems. And this is why it has to be human in a loop. Maybe one day that'll change, but these are non-deterministic. So that's really important. But it is impressive what you can do today. And this is coming soon, but sort of we go through this whole thing where it was like, we can root cause it, and we're gonna like massively shift how Sentry works, by the way. Like if you end up using this functionality, which is gonna be like a paid thing, because obviously we know LLMs are expensive, this is no longer gonna be a widget. This is gonna be the front and center primary workflow of how you reason about Sentry. But it's like you go through, you see the bug, you agree with the bug. Wouldn't it be great if we could just automatically propose solutions? Sentry, however, is not in the coding agent business. We have one. It's not that good. It's fine, but it's not that good. Cursor is, Anthropic is, Microsoft is. And so we're working with them, these companies, to try to bring that directly into Sentry so you can use the best of everything. We have all this debug context. We have Sear, the debugging agent. We'd like to just like hand that off to our friends at Cursor. And so soon we will have this. I don't know. It's kind of done today, but does exactly what you think it does. But this is coming very soon. And this works. This is a different error than what I was describing earlier, but this was actually the fix. It's kind of a silly fix. It's just like I didn't read the source code to figure out what the schema should be. But if you're operating against somebody's upstream API, which effectively is what I was doing, you might not be able to. They might not have API documentation. Maybe the API isn't technically supposed to be exposed publicly. There's a lot of reasons you might not know what's going on. And our sort of dream, what's my next slide? Okay, our sort of dream here is like, what if we could fix the bottom 10% of bugs? The easiest 10%. What if we could fix them automatically? And maybe that's not we automatically land the change. I do have a POC that does that, which is a little bit scary. But what if we could take every trivial bug like this, and you could wake up to a queue, and it's like, yeah, looks good to me, looks good to me, looks good to me. That is very interesting, and that is actually practical to do today with a little bit more investment. It is not practical to imagine agents writing all the code for us or fixing all the bugs for us, but at least it makes it a lot faster. And so it's an efficiency thing at the end of the day. And with that, I think because I'm not totally sure how we are on time and I don't want to run super over, that is my presentation. I'll be around if you want to chat. I don't think we're doing Q&A, but I don't know how. But either way, if you have feedback, I'd love to hear it. This space is super exciting. I've written all of my code with Claude Code for the last 6+ months. And to be clear, that is production code at Sentry. So it is a fascinating time, but it's not everything the internet leads you to believe.
Thank you so much, David. I see the first hand over here.
Hey, David, I'm Taylor. I have a question for you. You spent a lot of time thinking about the JavaScript ecosystem and thinking about bugs. What's your maybe best way that you think about like handling errors, which are always painful in JavaScript? Like some people say rewrite your whole app in effect, which we already heard is not always practical. Some people like return types with errors. What do you think?
I come from Python, and so I'm not a fan of current Python, to be clear. I prefer exceptions as control flow personally. I think use a web framework, for example. It's phenomenal. Throw new 404 or something like that. Great way to do it. I will say it is quite hard to get this right, and it's particularly hard in things that involve the UI, which we don't write JavaScript for the backend. Like, we can all be honest in this room. I don't know there's a good answer. Because I think, like, ideally, you just have layers that can bubble up those errors and capture them in a really effective way. But I'll tell you what we see, which is particularly frustrating at our company, is this is always like this, like, sort of production observability, whatever you want to call this, is always like the second-class citizen when it comes to, like, frameworks. Not coming in like Monster or anybody else in particular, but, like, it often isn't what people have in their mind when they're building the thing. And there's been more than one person I've had to teach what tracing is and what middleware is in very large, well-used JavaScript frameworks. So I don't have a great answer. What I do in every single project now is I build a set of utilities that effectively log errors, and then I build every abstraction I can find in whatever technology I'm using that captures those errors, which is usually numerous and usually poorly documented. I think it's getting better, but I don't think something like effect is the answer, to be fair. I also don't think implementing like Go return types or something like that is the answer either. I think you got to work with the primitives of the language. And unfortunately, the primitives of the language are not great. And so I think as long as you spend the time and you put in a bunch of calories to make it okay, it's about as good as you're going to get. But pattern-wise, I don't know. It's whatever you're comfortable with.
Your comment about never needing source maps, again, is really interesting. Is that because in the future you can imagine that AIs will be able to take a minified stack trace and your source code and be able to just map it one-to-one? And has Sentry played with that idea and like tried it?
I don't know if we've tried that. I think it's you actually no longer need to see the source code. And this we have tried. You can vet it very easily. If you plug in like a really junk JavaScript error, it can pattern match against like sort of the behavior of it, and especially in Sentry, which is a little bit more complicated than local development. Because we have that trace connectivity, we can see all the HTTP requests. We can roughly trace what's going on, which is kind of like a stack trace. We kind of know the point of the error. Even without that, it's quite impressive how, lucky they get is how I would describe it, because it is RNG, But if anybody's set up source maps, by the way, and if you're not familiar, it basically translates the transpiled code to hopefully what you've written with many layers of indirection, and it's quite a pain in the ass to get set up correctly. I think, we have this era where we even think about Sentry. So once upon a time, pre-Sentry, every error was just in a log. It was like maybe there's a stack trace dumped in a log, good luck, it was awful. And then when I built Sentry, I was a big Python developer, and Python has very powerful reflection. And what I built was the initial issue crash report, and instead of a log, it was like, here's every bit of data you could possibly need that's more human readable than what a log is. And the first thing that was important there was source code. It's like, I'm gonna show you source code versus just the machine language or something. And that's the same with like source maps versus not, right? This to me is a way we can evolve that even more. Instead of showing you, the enriched stack trace or something like that, why don't we just show you the reasoning steps, the root cause, and it's pretty accurate, to be quite honest with you. And it's like, obviously, like it's not gonna be 100% of the time, but it's like you can always fall back to the advanced tools. And so that's where I think it's going. But I don't know if, I'm not confident, in fact. I would say it's unlikely that you could replicate what source maps do with just an LLM. At the very least, it'd be way too expensive. But I just think we'll just need the stack trace a little bit less, or a lot less maybe, probably a lot less.
Thank you so much. Last question.
Hi, my name's Kyle. The other day on Twitter, you were talking about Sentry's MCP server's agent mode, which, it's really interesting to start seeing, when, people that are solving hard problems converge on similar patterns. And it seems like that this is a pattern that's starting to happen a lot more with MCP, which is instead of giving the agent a bunch of tools, people are starting to treat MCP like a way to kind of give pluggable sub-agents, essentially. So whether it's for Sentry, Sentry sub-agent knows how to locate context in Sentry much better than just giving my agent access to 20 Sentry tools. Stagehand, browser-base's MCP server is kind of similar. The agent just expresses an intention. Go find this thing on the page and click on it, rather than having to interact with 40 playwright tools. I'm curious how you guys landed at this pattern, and if you think that that's the direction that MCP continues to evolve in.
So I'm not sure. I think if anybody's not familiar with MCP, the big challenge is a lot of people, let's be honest, the big challenge is GitHub wrote a really poor MCP server and everybody uses it as a reference. And it's poor because it has dozens of tools exposed, which agents can't handle, like there's benchmarks on this. And then it consumes tons of tokens. And we all know the token thing is a problem right now. That'll improve. What I think is interesting, if you look at, we design our MCP specifically for coding agents. We say that is the intent of the product. And in coding agents, you're expressing things in natural language most of the time. And so I actually think it just makes sense. It's just a better experience. And so that's one. I think the other thing that makes sense why you would gravitate towards this, it's not the be all end all, is I want to influence more of what's happening. The only way you can do that with tools is through the tool description and parameter descriptions. You plug in an agent, all of a sudden you can overload that context to your heart's desire, doesn't matter. You can curate it around your own design. And we did this right off the bat with embedded agents inside the MCP for our search tools. And so you wanted to look up something about traces. Good luck getting an agent to craft the right query parameters for your API. And this is one of the problems with people's designs. And so immediately we moved that and we said, okay, pass the natural language expression all the way through to the search agent, which is just a tool, right? And then inside of that, we have a bunch of tools that are completely separate that know how to query the data, know how to structure the query. And it just gives you, if your goal is the best product, it just allows you to make the best product. Now, the counter side is it's not really composable. And so I don't think it's a be all end all. I think for some situation works really well. And I'll tell you the agent mode. And so everybody, if you're not familiar, agent mode is this thing that I shipped the other day, which basically just takes all the tools in our MCP and collapses them into a sub-agent. And so you have one single tool with one single description. So it's really lightweight. But what happens immediately is it's not as organic in terms of when you're just typing whatever you're typing into your prompt, it doesn't always pick up. And so we got to tune it a little bit more, to be fair. It was like very fast and lazy. But that is one of the challenges too, is like the less context you have, the less reliable it's going to be. So not everything is about saving tokens. I should be very clear about that. Like, I want to use the maximum number of tokens in every task. That's fine. I want reliability and accuracy. I don't want to have to prompt the thing 800 times to get to the answer I want. And so I think we're still early figuring that out, and the constraints we have right now are just like rough. And so the hope, I think, from the entire industry is those constraints improve, because otherwise we're going to be quite limited in what we can do with LLMs and agents in time. So.
Thank you so much, David. We're up to time, and looking forward Sentry to release the self-healing agents in the future to help us solve the bugs. Please give David a round of applause, please.
Cool. Thanks, everybody.